Yes guys, what's up? Welcome back to question 8. Let's have a look at this one. It was a Euclidean geometry question. It says here in the diagram below, O is the center of the circle. We know already when they speak of the center, which angles are we supposed to start thinking of? We must start thinking of angle at the center is equals to twice a angle at circumference. These are some of the things we must start thinking about, guys. When you read the question, you must know which angle you're supposed to think about. So already here, like I taught you earlier in the other videos, we are already thinking of angle at the center twice angle at the circumference. We know that is going to take part because we do have a center in this question. All right. So A, B, and D are points on the circle. Okay, it's fine. Let's go and acknowledge those points A, B, and D. We see those points there. B, C, it's a tangent to the circle at B. B, C, which is this line here, which is this line here. This red line here is a tangent. All right. So if they speak of a tangent, which angles are we supposed to think of already? We're already thinking of tangent theorem. All right, this is how I have taught some of my learners when it comes to Euclidean geometry, because they tend to think that it's a bit difficult, but when you read a question tells you which questions are going to be involved. Right. So if they speak of the center, you know, anything that has to do with radius, diameter, those angles are involved. If they don't speak of parallel lines, guys, there's no way that in this question you should be thinking of a angle of inclination. They didn't say anything about parallel lines yet. All right, so if they don't say anything about any angles that are related to any theorem, don't think of those angles. All right, so now they said there's a tangent at B, triangle. We do have an angle here is 22.5. The chord AD is produced to C. All right, we see chord AD produced to C such that we have got two sides that are equal. If you have got two sides that are equal, what does that mean? It means that if you've got two sides that are equal, you should have two angles that are equal. Guys, you do remember this triangle, isosceles triangle. If you have got two equal sides, you should have two equal angles. All right. Okay, let's go ahead and read 8.1. It says determine, give reasons the size of these angles. Now they said 8.1.1 angle. We're looking for this angle here. All right, angle A1. Now let's have a look at this one. We can come here. I can already see that in this triangle here, okay, in this triangle here, we do have this as a tangent. So now we have got triangle A, B, and D. Okay, triangle A, B, and D. Then we do have this angle here. So this angle here should be equal to that because the line BC is a tangent. All right, so let me just extend it here so that you guys can see. So now we can come here and say, okay, in triangle A, B, D, okay, in triangle A, B, D, we do have a angle. Yeah, we do have angle A1. It's equal to 2.50, and then our reason will be tangent theorem. Okay, there you go. Tangent theorem. Why? Because you do have a chord here and then they join here on this triangle. I have seen most of the learners that you do have a chord here, there you go, and then you do have another chord here, there you go, and then that's your base there is joining here. So therefore A1 should be equal to that angle there. All right, okay, let's move on. Now they want us to find D1. All right, let's have a look. If we look at in this triangle here, triangle A, B, and C, we do have here, you do have this side here is equal to that side. So therefore ultimately it makes this angle here to be 2.5. What you can do here, you are looking for D1. All right, there's many ways to kill a cat, guys. You can either find D2, okay, by saying sum of angles in a triangle. You can find D2, or you can rather say exterior angle of a triangle is equal to sum of the internal opposite. So what does this mean? It means that now in a triangle, which triangle is this one? It's a triangle B, D2, and then C. In this triangle, what do you have? You are going to say angle B is equal to angle C, which is equal to 2.2.50, and then our reason is that angles opposite equal sides. Okay, cool. And then what else now? And then after that, you can say D1 it's equals to sum of C plus that B there, and then our reason will be exterior angle of triangle. Okay, it's equals to the sum of the internal opposite. So therefore it's going to be 225 and then plus 2.25, which gives us how much? Which gives us 45. All right, so therefore that one would be 45 degrees now. Great stuff. So moving right along now, let's have a look at they want us to find B2. All right, they want us to find B2. Okay, so now B2, this is how you would find B2. Let's see, let me use a different color, guys, so that you don't get confused here. B2 is sitting right here. That's the angle that we are looking for. All right, but guys, if you have a look at this, you remember something like this when you're doing the theorems, that if you have these angles here, and then this is at the circumference, angle at the center is twice angle at the circumference. Guys, you still remember this? All right. Okay, so else there's many ways to kill a cat. Or what you can do, if you have a look at this one, guys, from here going here, this is a radius, so this is a radius, and even here this is a radius. So if you have a look at this radius here, and then also this tangent going there, if you look at this, it's going to be perpendicular. The tangent is always perpendicular. So the total of this angle here, let me come here, the total of B, okay, the total angle of B, okay, let me say, okay, angle O B C, it's equals to 90 degrees. And then what is our reason? Our reason is that a tangent is always perpendicular to the chord. That's our reason. So ultimately, therefore, this makes angle B to be equal to 90. All right, the total of angle B is equals to 90. However, B is also split into another one. So therefore, B2 would be equals to 90 minus that 22.5 there, which will give us 67.50. Okay, I hope you guys are following. So this angle here is equal to 90 because of that line there, which is perpendicular to this tangent here. All right, great stuff. So now let's go ahead and look at O1. If we have this angle here, that is at the circumference, this one is at the center. So therefore, we know about this theorem, the angle at the circumference is twice angle at the center. All right, so therefore, basically, this one should be straightforward. Number 4, which is 8.1.4, is going to given that O1 is equals to twice angle at the circumference, which in this case is equals to D1. D1 in this case is equals to 45. We just calculated it there, so therefore this should give us 1, it's equals to 90. All right, great stuff. And I think that's how you would deal with this one, guys. Under normal circumstances, I wouldn't start by answering the questions here. I would start by dissecting the diagram, but for the sake of understanding and explaining each question step by step, I started by answering without exhausting the diagram. So what I would advise under normal circumstances, you should exhaust everything here, so that when you come here you don't take time, even if it takes you 3 minutes to find all the angles here, or to find angle at the center, angle at the circumference, the radius is perpendicular to the tangent, Tanchord theorem, and things like that. If you really need to start by dissecting the diagram, then it will be easy for you to answer the question thereof. All right, let's move on to 8.2. All right, 8.2, it says here, prove giving reasons that O, which is this one here, which is O. All right, let me mark it properly, which is OA, it's parallel to this angle here. It's parallel to BC rather. So to deal with this one, guys, it's simply straightforward. You just have to prove. We know that this angle here is equals to 90. This angle here is equals to 45. This one here is 90. So the only thing that we need to do to have parallel lines, we just need to prove that angle C, which is this one here, because they are saying it's parallel, angle C should be equal to A2. All right. Yes. Because now what do you have here? We have got here, it's a 90 degrees here, and then what else do we have here? I think let's go back to our diagram and get our angles. That angle there is equals to 90. Okay, we have got A1 is equals to what? 22. Oh, okay. All right, great. All right. So now what you would have there, you just need to prove that this angle and that angle, they are equal. In this case now, what we can do, we can come here and say angle 2, this is radius, therefore this is radius, and then we know what is A1 here. A1 is what? Is 22.5. all right, A1 is 22.5 as well. So if this is 45, so what you can say here, we can say angle 2 is equals to 22.50. Our reason being angles opposite equal sides. Okay, so therefore if A2 is equals to 22, if A2 is equals to 22.5, therefore we also know that C is also 22.5. We did prove it initially because it's equal to opposite sides here. So, and then also C is equals to 22.5 as well. So therefore if these two are equal, therefore it means CB is parallel to OB, and then the reason is that these two angles, they are what? They are alternating angles, because they are alternating angles. All right, and that's how you would prove that one there. All right, now let's move on to 8.3. 8.3 says here, if it is further given that the radius is equal to 12, so which means the radius here, which means OB is equal to 12, and then also OA. Calculate the length of BC. Calculate the length of BC, which is this one here. All right, so if you've got these two radius here, calculate the length of BC. So if you've got here, you've got that triangle there, it should be a right angle triangle, if I'm not mistaken. Yes, it is a right angle triangle. All right, so now let's have a look at this one. I think here it will be just simple, straightforward. We should apply Pythagoras theorem as well. All right, let's see here. What do we have here? On which triangle are we going to do that? I'm just going to try to clear out my triangles here. We're going to do that in triangle AB. I'm just going to highlight it here. Triangle AB. We're going to do that here in triangle AB. And then what? OB. And then OA. So in this triangle, because we know that here it's 90, we know that here it's 90. So, and we also know that AB and then AB and BC, they're equal, and they're equal. AB and BC, they're equal. All right, so now what do we have? We've got this triangle here, guys. Just gonna simplify it here. You have got A there, you have got B there, you have got O there, you've got 90 degrees here, and then what did they say? They said the radius is 12, so you've got a 12 here, and you've got a 12 here as well. Then you have got yes, that's what we have here. Okay, so this is our hypotenuse here. So if this is our hypotenuse, which is R, so it's going to be, you're going to say AB squared is equals to OB squared plus OA squared. This is what Pythagoras theorem, guys. So now what you're gonna do, you're just gonna come here and say 12 squared plus 12 squared, and then we take the square root of that. So it is just going to be AB is equals to how much? AB is equals to 12 square root of 2. That's what I'm getting. All right, but however, when you found this side here, when we found this side, you will remember from our question, we already proven that C is equals to A1, which is equals to 22.5. all right, let's have a look at C is equals to A1, which is equals to 22.25. so if C is equals to A1, then it means these two sides here, they are equal. All right, on which triangle, you may ask, and I know what you guys are thinking. You're thinking, oh, now this, I'm now confusing you guys. Okay, I'm gonna make it simple for you. Let me highlight to you the triangle I'm talking about. We are talking about this triangle here, guys, A and C. So basically this triangle right here, this one right here. All right, so we are referring to this triangle here. So now if it has got two equal sides, we already found this side here, the angle are the same, so even BC should be the same. So this basically means, therefore, AB should be equal to CB. What did the question ask? The question asked us to find BC, so therefore it means BC is also equal to 12 square root of 2 units. And that's how you would deal with a question like this one, guys. If you have got more questions, please let me know. If you don't understand, I don't mind repeating this question and do it a little bit different, since there are many ways to kill a cat. I am Gaston Mapala. Let me see you on the next upload. We will be doing question 9 of this paper.